What is a factor? So a factor is a number that can divide into another number without leaving a remainder. So I'm sure you've done a factor in grade 9, in grade 10. You're going to be looking at factorizing. Stay tuned for this video. So today we're going to be talking about factorizing. So what is factorizing? So factorizing is just taking many terms and making them into one term. So it's just kind of simplifying them. So let's take a practical example. For example, you can say that you've got a school with 1,000 learners. So if you are going to factorize them, I'm not going to call them one by one and be like Chantel, whoever, this girl and this girl and this girl. You're not going to finish 1,000 learners on one page. So to factorize them, you're just going to just say that these learners are from what school. I'm just going to name that school is because they fall under that school. So the school is the main category in which all learners fall into. So factorizing is just basically something similar to that. So remember that a factor is any number that you can divide into another number without leaving a remainder. So supposedly we look for factors for 6. So when we're looking for factors for 6, we're going to look for all the numbers that divide into 6 or that get into 6 without leaving any remainder. Remember, when it leaves a remainder, it gets into a number certain number of times and then leaves a remainder. It means that remainder was not able to reach another number. So in this case, for factors of 6, okay, just going to look at the numbers which can divide into 6 without leaving a remainder. So those are 1, because you can say 1 multiplied by 6. Those are 2, because you can say 2 multiplied by 3. Those are 3. You can say 3 multiplied by 2. Those are 6. You can say 6 multiplied by 1. So you can see that this is actually a reverse here. This is a reverse of this, because when you have 1 here, you have 1 here. When you have 2 here, you have 2 here. When you have 3 here, you have 3 here. 6 here, you have 6 here. As you can see, this is actually a vice versa. So here are the factors here. All of these are factors of 6. So these are the factors of 6, meaning that these are the numbers that can get into 6, or these are the numbers that can divide into 6 without leaving any remainder. Therefore, we have to factorize now. So we're learning how to factorize. So it's just making something huge into one term. You're just simplifying it kind of. So for example, you are given 2x plus 5x. So this is an expression which involves 2x and 5x. You can see that here we've got 2 x's, you've got 2 and 5. So this is the first method of factorization we're going to be talking about today. This method of factorization works like this. You're just taking out the common factor. So the common factor here, you analyze it, do a sort of analysis to see what do you have here and what do you have here. Here you've got 2, as you can see here, it's visible, 2 and 5 there. You can see 2 and 5, they are not really common. So it means 2 is not a factor of 5 because 2 cannot get into 5 without leaving a remainder. It says to get in 2 times and leave a remainder 1. Therefore, to be able to factorize here by taking out a common factor, you look at which common factor have you got here. So what is the same thing that is found here in this term and this term? You can see that you have got x in both sides. Therefore, what you have to do is to factor out x. So you remove x from what? From this whole thing. You factor out x and put it on another side. So in this case, what do you do next? You put a bracket, which shows that this is multiplication. So what do you do here? You use this very same x. You divide it here, and then you also divide it here. So here, let's kind of do a table here. If you're going to say 2x divided by x, you get 2. And if you're going to say 5x divided by x, you're going to get 5. Reason being, when you're dividing these x's are the same, when you're dividing these x's are the same, we therefore remain with 2 and 5. So here, if we're going to write this down, you're not going to write 2x in here because you've already taken out the x, therefore you just write 2 plus 5. So this is simply taking out the x out of the expression and multiplying it separately to this. So this is the basic method of factorization by taking out the common factor. Okay, so let's look at another example for the factorization by taking out the common factor. So supposedly you've got 4x plus 16y. So this case is now different. Visibly here you cannot see any common thing. So when you're looking at this, you cannot see anything that is the same here and anything that is the same there. Therefore, you have to now deepen the knowledge. According to the definition of the factor, it says a number that can divide into another without leaving a remainder. Therefore, what you have to do here is just to come and look for that number. So you can see here we've got x and y. X and y can never be the same. They are unlike terms. So don't even think of factorizing those because they are unlike terms. They are not the same. It's like a table and a chair. You cannot add them. You cannot do anything to them. So they just remain separate. So forget about the x and y. So you move towards to the 4 and 16. So let's look at the factors of 4. Let's actually look at the factors of 16 because it's the large number. So 16 has got the following factors: 1 multiplied by 16, 2 multiplied by 8, and then 4 multiplied by 4, and then what else have we got? 4 multiplied by 4, 8 multiplied by 2, and then 16 multiplied by 1. As you can see, this is the factorization method. It's the same thing. This side is just vice versa to that side. So this is 16 here, 8, 8, 4, 4, and then 2, 2, 1, 1. So you can see that these are all the factors of 16. Therefore, you have to look for a common factor. By common factor, we are referring to exactly which factor do we have in this whole thing that can get into this. So you can see that we have got 4. 4 multiplied by 4 is equals to 16. Therefore, now you know that you have 4 as a common factor. Therefore, that common factor, you have to factorize it. You have to factor it out. So 4 is the common factor. You write it down, and then 4, you put a bracket for multiplication. Therefore, why do you put the bracket for multiplication? Is because this is multiplied. So this is multiplication. Therefore, you do the very same thing you did here by dividing with what? With this common factor. With this common factor. So let's divide 4 into 4x. So let's make another box here and say 4x divided by 4, and also have 16y divided by 4. So you can see that 4 and 4 are common here. Therefore, they divide each other and they result with x only. And then you can see that 16y, 4 can get into 16 4 times. The y is not affected at all. The y remains there. It's because 4 and y are unlike terms. Therefore, 4 cannot get into y. A chair cannot get into a table, if you understand. Therefore, you have to write this x here, and then you have to write this 4y here, plus 4y. So let's look at a reason for this plus. This is a plus because this is plus already. This expression was added. So this term was added to this term. Therefore, you have to put a plus. So let's kind of do a reverse just to understand exactly how this works. So if we are going to do kind of a reverse, remember we did the FOIL method last time, whereby you expand a number. So you can see this is 4 multiplied by, let's rewrite down, 4 multiplied by x plus 4y. So as you can see this, you have just to multiply this 4 into this and then multiply it again into that. So let's see. 4 multiplied by 4x is 4x, and then 4 multiplied by 4y. Here you have to multiply the 4 and the 4 to get the 16, positive 16, and then you have got y. The y is not affected at all. So you can see that this expression, by the method of FOIL, it has gone back to this unfactorized or to its unfactorized form. So actually, factorization is the opposite of the FOIL method or the expansion method. Thank you for watching. Stay tuned for another video that's